Welcome to the Eventual world, the world of asynchronous microservices. To understand event-driven microservices architecture, we need to talk about transaction models. We have two transaction models. The acid transaction model, which means atomicity, consistency, isolation, and durability. And we have the base transaction model, which means basically available, soft state, and eventual consistency. ACID transactions are related to relational databases. When you have consistency, strong consistency, you have two-phase commit and other techniques. Base transactions are supported by NoSQL databases. ACID transactions are related to synchronous calls, synchronous invocations. When you make a call and you wait for a reply, the processing of the reply is synchronous. Base transactions are related to a asynchronous model. You make a call and eventually you get an answer, maybe sometime later. There are implications of event-driven architectures and event-driven updates on databases. First of all, your business model must support eventual consistency. The data will be consistent sometime later. Your application must support out-of-order updates. The updates can occur in a different order than you are expecting. You need to prepare a reconcile process, a process which checks the consistency after some time to make sure the data is not inconsistent. Let's see how the ACID strong consistency model works. We have an originator. This originator updates something on a resource. It sends an update to a resource manager. This resource can be a database, for example, and made another update to another resource manager, and another update to another resource manager. We have 3 updates in different parts of the application. When all the resource managers say they are okay to commit the transaction, the originator commands them to commit the transaction. So what happens? We have two-phase commit. This is called two-phase commit. The first stage, all the resource managers communicate that they are ready to commit. And after that, the originator commands the commit. The result is the data is always consistent. And more important, no updates can happen without a transaction, without a request. We have a hard state. The state of the data is the final state. If a transaction is running, you cannot get the state. You only get the state after the transaction finishes. What is the base eventual consistency model? We have the same thing, we have the originator. But this time we have components called event bus. You can call it different name. For example, asynchronous message component or queues or topics or so on. These are components that receive messages and relay messages. In this case, The originator asks something and it gets a reply, an immediate reply, because it's basically available, the BA in base. This reply is not the definitive one. It's just saying, okay, I received your request. Later on, a message is posted on a topic, for example. Someone will listen to this message, updates the database. The information on the other databases is outdated. The data is not consistent between the three data stores. Okay, this is expected. Sometime later, another originator makes a request to another service to get the information. Depending on where it gets the information, it will be a soft state, not the hard state, not the final state. As you can see, we got the state from a database that is not updated yet. This is okay, because a soft state is part of the base model. Now, a message is received by another service that updates a data store and puts another message in another topic, and then the final data store is updated. Now the three data stores are consistent. But we can note that this update occurred without a transaction, without a request. This is eventually consistent model. We can have updates without requests and out of order. That's a characteristic of the base, the eventual consistency model. But sometimes things fail. Let's suppose the originator makes a request and receives a reply. A message is posted on event bus. When it's read, it causes an exception on a listener. So what happens? The data store is not updated. Normally, we use dead letter topics or queues to store problematic messages. The message is not on the event bus, is in the dead letter topic, and will stay there. You can see that the update did not occur. Sometime later, another update is requested, the message is posted, it's read, and it's updated on the data store. You can see that we skipped one update. But this update is okay, so we have a missing update in the dead letter. Sometime later, you have a reconciler process. A dead letter solving process may be a manual thing or something. It will fix the message and put it in the event bus again. Now, the message is received and will be processed. But at this time, the data store is not consistent because we had out of order updates. Can this happen? Will this cause a problem to your business? You need to be aware of that. So, my advice is, don't follow dogmas. Eventual consistency is a good model, but not for all business model. You need to think about your business need and your business model, and put the user experience up front. For example, are your users ready to receive a message just eventually? For example, they buy something and then they receive a message that thing is not on shelf. You need to buy one to sell them. Your business model must support this.